Okay, good afternoon in Europe, good morning in the Americas, and good night in Asia. Welcome to the second LUCA talk. LUCA is a business unit of Telefonica related to big data. Everybody has heard a lot about big data, usually in the context for improvements, optimizing business processes, or reducing churn, or even marketing campaigns. However, data can also be used for the greater good, and that is what is called big data for social good. That will be the topic of this webinar. And my name is Richard Benjamins, and I'm going to explain you something about this initiative. Let me share with you the presentation, so you won't see me again, but you will see the slides and you will hear my voice. Okay. So probably there is some delay in the presentation. If we go to the first slide, you see here the 16 Sustainable Development Goals of the United Nations. Wait a minute. No, you quiero ver la pantalla. So these are things like no poverty, no hunger, good health, good education, and those 17 development goals have targets for 2030. Those are the things the United Nations wants to achieve to have a better world. There are 161 targets associated to the 17 goals, and each of those targets are measured to 241 KPIs. If you look below at the screen, what you can see is different types of KPIs: Tier 1, Tier 2, and Tier 3. Tier 1 KPIs means that they know how to measure them and the data to measure them is available. Tier 2 means they know how to measure it, but there is no data available. And Tier 3 means there is no methodology and there is no data. So that is really a problem to achieve those 17 development goals. If we go to the next slide, we see some examples of the use of big data to achieve the Sustainable Development Goals. Big data is a great opportunity to measure and progress the Sustainable Development Goals. Let's see a few examples. So first of all, there is payment data. Payment data can come from banking sector or it can come from supermarkets. And if you have a lot of this data anonymized and aggregated, you can actually make an estimation of a consumer price index or even of poverty rates. So the poverty rate in different countries. Search query is another type of big data, all very well known from Google. And remember the example when we had the influenza breakout, and actually they could be tracked and even predicted quite well using queries in Google that people did when they were interested about this type of disease. This is also an example that can help the Sustainable Development Goals. For instance, if you just look at the light emissions produced on Earth, that gives you an estimation of the GDP of the different countries, because light is related to growth. The same with floods. From space, you can identify different types of floods. And then finally, mobile phone data. That is what we actually will be talking most about in this webinar. Mobile phone data is also a indicator of human activity, and that can be used to estimate, for instance, literacy rates in countries, because people who use a lot of calls, but they actually don't use SMS. One of the reasons can be that they are not able to write or read. So there's also an indicator for this kind of thing. If you look at the projects that are underway using big data to achieve those Sustainable Development Goals, and now we are on slide 4, you can see that the most popular projects are related to no poverty. It's the biggest struggle. Then it's about hunger, to eradicate hunger in the world. Health is important. And also the last goal, partnerships to achieve the other 16 goals. Yeah? And if you look at here at the right side, you see the types of private data that has been used to estimate the impact of for the SDGs on those areas. And what you can see is that mobile data is the most popular one, and then satellite image, etc. This is all private data that is ownership of companies, but it has been shown that those data sets can have value to measure and to achieve those sustainable development goals. Now, if you look specifically at mobile data, and if we speak about mobile data, that means that every mobile phone in the world is connected to a certain antenna. Yeah? And this mobile phone that can move around, and then it switches from antenna. From the same mobile phone, calls can be made or internet connections can be made, and all that leaves a register in each of the antennas. Yeah? Mobile phone data, because in this sense, it reflects a kind of human activity on the planet. Yeah? Now, if you look here, you see a screenshot of some of the KPIs of the Sustainable Development Goals. So you get an idea of what is the things that the United Nations want to measure. Things like the number of deaths, missing persons, and persons affected by disasters, yeah, per 100,000 people. Now that's something that through mobile phone activity you could be able to measure. And it's especially important to look at the tier 2 and tier 3 goals, because that is where the United Nations don't have any information to measure. Yeah? If we look at mobile phone data in this sense, actually it gives you 3 kinds of main insights. Yeah? One is about activity, because if people make calls or if people connect to the internet or send texts, that generates activity. Yeah? And the more activity, it gives an indication of human activity in a certain area. Then there is mobility, because people move around with their handsets. We can see this movement reflected in activity in antennas over time. So that tells us, let's say, mobility patterns of groups of people moving around within a country or between countries. And finally, communities, because people who are calling each other, they are in some way connected and they form communities. And those communities are also very relevant, because if one member of a community is affected by something, then there is a higher chance that other members of that community are also affected. Let's move to the next slide, and we will see in the following slides a few examples of what we've been doing in the past. Yeah? This is slide 6, and this is about a flooding situation in 2009 in Mexico. And what you see in the map is flooding of a river, and the bubbles represent, let's say, the flooding activity when there is more water coming out of the river and actually invading land. And on the bottom side, you see activity measured in the antennas close to those areas. And obviously what you can see is that there is a clear correlation between a natural disaster happening and a human activity reacting to that. Of course, if something bad happens, then people want to let their family and friends know that they are all right. So there is a correlation between mobile phone activity and natural phenomena. That is something that we learned here and that we need to try to exploit to support those sustainable development goals. Here is another example on slide 7, which is about diseases. In this case, it's the swine flu that happened in 2009 in Mexico. This is mobility data. It's about how people move around in a country. And here what you can see is that when there was the swine flu pandemics in Mexico, the government looking for measures to contain the contamination. So they decided to have alerts to the population. That didn't work, so they closed down some of the shopping centers, and then they shut down many things of society, including schools and large events, etc. And what you see in blue is the normal behavior of mobility we see in the country. And what you see in red is the actual mobility after the measures of the government. So you see there is a reduction in mobility, which is actually what the Mexican government wanted. But for the government, it's very difficult to measure this impact. But since we know now that human activity is reflected in the antennas of mobile phones, so if you look at the data in the antennas, you can actually see that it had an effect. So this is another example in the past where we learned how those things are related. Now, if you look on the next slide, on slide 8, we're going to look at a specific event, which is an earthquake, and we're going to see different ways how is that reflected in mobile phone data. On the left side, you see a small video where what you see is of mobile phone activity just before, during, and just after an earthquake. So when the earthquake strikes, this was the 7.1, you see a lot of activity in some areas and less activities in other areas. So probably that means that the areas where there is more activity are more affected by the earthquake. And that is very important information for humanitarian agencies to send support to certain locations. That was an earthquake in Mexico in 2012. Luckily, there were only 3 casualties, but there was a lot of other damage. Now, if you look at number 2, the middle figure, that's a different kind of reflection in mobile phone data. So this is just international calls, which also go through the Telefonica wholesale business. And this is the earthquake that happened in Italy last year. And what you can see is from about 6 other countries, you see a line, and then there is a peak in all the countries on the same day. And that means that is the day when the earthquake happened. And then many of those other countries had a peak in calls to Italy. So this is also reflecting human behavior as a reaction to a natural phenomenon, in this case, a disaster earthquake. And the third way that the earthquake can be reflected in data is that it generates difference in the mobility patterns that areas normally have. What we see here is footfall data. That means the number of mobile phones at a certain location at a certain time. And what you see, so in general, you see the baseline, but you see a few peaks and valleys, and that is where the earthquake happened. So you can see that actually those things have an impact on human behavior of people. So all examples of the impact of natural phenomena in earthquake and on the mobile phone data. Now we go to the next slide, slide 9. Now we'll have a look a bit more in detail on some of the disasters happening in Colombia in 2015. Notice that those are not the biggest natural disasters that there have been. So this was not the earthquake like Haiti. It was not the tsunami we had in 2004. So those are huge, and those will be noted by anybody in the world, etc. But there are a lot of smaller disasters that nobody knows about except for the immediate environment. But still, there is a lot of damage done, and there is a lot of help needed by humanitarian agencies. The problem is that those agencies, they don't have so much information about it. Maybe it reaches them very late, etc. So here's the opportunity for big data for social good. We can create systems that generates alerts when those things happen, and then that helps those agencies to improve the support. We will see 3 examples of 3 natural disasters. There is a landslide on May 17 in Colombia, in Salgar. You can see it on the map where it more or less is located. 62 people were killed. There was a flooding on July 22. More than 1,600 families that were impacted. And there was an earthquake, 6.6 on the scale of Richter on March 10, 9 injuries and almost 300 houses destroyed.
Not something that would reach the news, but still impacting a lot the life of a lot of people. Now let's see how those different disasters are reflected in mobile data. Yeah? Again, activity that is generated by mobile handsets in our network. On the left side center top, you see the earthquake. There you see calls made every day, and we measured it for every hour. And what you clearly see is on March 10 is a big peak of calls. Yeah? And this is actually exactly 5 minutes after that the earthquake happened. So very good indicator of what was happening. If you look at the flooding, you see again, on a daily basis, but measured every hour, you see all the calls, and this is different. This is not the number of calls. What we detected here, that it's actually the calls that have people tried to make, but that were not reaching the other destination. So we call it non-terminated calls. So there can be a reason that the network was congested, was overloaded, and therefore many people tried to call and tried, but the calls didn't come through. So it can be also an indicator that something strange has happened. And actually you see clearly a huge peak. Also for the flooding on the top, on the bottom left, the movements, people moving around, and you see clearly that during the flooding there was less movement during those days, and then after the days it went up a little bit again. That's the black line going up. And the landslide, we again have the calls made during the days, but on an hourly basis, and you also see clearly that is there a strong increase in the activities around the event. Yeah? So different disasters, they are not always reflected in the same way in telco data. And sometimes you have to look, and that's why we have our data scientists, to look at those patterns, to look at not only activity made, but also anything that is abnormal from the normal situation may indicate an alert. Now, how can we help humanitarian agencies with this? So what those agencies normally do, they have 3 phases for managing a disaster. The first one is alert, and the earlier the alert comes, the better. So it would be perfect to have this data all available in real time, if not at least on a daily basis. Secondly, understanding what is happening, what are the areas mostly affected, how are people moving around, fleeing from the situation. That's what I call critical response. And the last phase is when everything is understood, slowly things are getting back to normal, and that is recovery monitoring. So 3 phases that humanitarian agencies like United Nations or UNICEF are working on a daily basis. Alerts are needed in hours. Critical response is a matter of days. Recovering can go from hours, days, weeks, up to months, and for the very big disasters, we all know, unfortunately, it can take years. Now, early warnings. So early warnings means that you look for things that are abnormal than from the normal situation. Peaks or valleys, as we've seen in the previous ones. And if you imagine you have a dashboard where you have the whole world, and sometimes you see something coming up red, which is a trigger that something abnormal has happened, and then you start investigating, is this something serious or not? And if you have this in real time, that is of a lot of value. We will see now a few things that we have to take into account from a data science perspective if we actually want to detect alerts. So on slide 13, basically what we need to detect is what is abnormal. So here you see again the same thing we showed earlier. Calls made around the earthquake. You see on the left figure a big peak on a certain day and even a certain hour. But you need to ask yourself the question: is this abnormal? Maybe there is a trend, there is an upgoing trend, and this is just part of the trend, or maybe it's seasonality. Maybe every 20 days there is such a peak because it's something that is normal. So you need to find out what's normal and what is not normal. And therefore what we do is we take away the trends information and we take away the seasonality
information. If you look on the left-hand side, you see already some seasonality information. For instance, the first peak you see is smaller than the other 5 peaks or 6 peaks afterwards, and then there is a smaller one. And that's usually the weekdays and the weekend days. Yeah? So you can't get any information from that. That's just normal. You need to find the abnormal. So if you take all the seasonality and the trends away, you get the second figure on the right, and you can see it's more or less flat, and then there is a high peak, which exactly corresponds to the peak we already saw. So what is important in big data for social good is that you look for let's say, the residual. Yeah, you take the trends and the seasonality away, and what's left is interesting. Usually, if you do big data in a commercial sense, you actually look for the trends and you look for the seasonality, because that tells you things about the commercial insights, and the residuals you consider as noise. But if you use it for disaster management, you have to look for the noise. Another interesting thing we saw now on slide 14 is 2G versus 3G. Yeah? Let's say in the developed world, we think, well, if you measure everything with smartphones, then you know everything there is, yeah, because everybody has a smartphone. But actually, it's not the case. Yeah? If you go to developing countries like Latin America or Africa, there are a lot of feature phones who have no connections to the internet, and it's not smartphones. So if you and we see this reflected here. Yeah? This is the earthquake. If you look at the 2G calls on the left side and the 3G calls on the right side, you can actually see that the impact, the deviation is higher on the 2G than the 3G. Yeah? Now, of course, this can have to do with that there is less 3G coverage in rural areas, because maybe it's not profitable for operators to deploy there. But it also may mean that smartphones are more expensive than feature phones. So in poorer rural areas, there are maybe no more smartphones. So then you need to have the feature phones to make an important conclusion. Yeah? And this is something that telecommunications companies have as a different differential aspect from, let's say, the over-the-top companies. Now, let's go to another alert for the flooding, a bit more detail on slide 15. So what you see here is, again, we've taken away the trends and the seasonality. On the top left, you see a very high peak of activities, of the non-completed calls again. And on the right, on the top right, what you see is the impact in the detail on an hourly level. Yeah, and let's say the line that is on the top reflects the antennas that are within 10 kilometers of the disaster. And the second line are the antennas that are between 20 and 30 kilometers of the disasters. Yeah? And you see that the farther you go away from the event, the less impact there is. Yeah? Interestingly, we also crossed this over with weather data. So that's the top left. And there you can see in gray very high peaks a few days before the actual flooding. And of course, you need, in order for flooding to happen, you need a lot of rain. So here you can actually, if you do an alert, you could do a first alert on the weather data, and then a second alert with mobile phone data. And then you get a very good understanding where you could even predict that things will happen. Yeah. On the top, the bottom right, what you see is actually the actual area in Colombia in the south where it happened. Then we go to slide 16, and this is more about critical response, about what happens with people immediately after the disaster, in this case the landslide. Yeah? So on the left-hand side, what you see is footfall. Footfall means where people are at a certain time of the day and at this certain location. Yeah? So what you see there, this is again taking away the seasonality and the trends. And what you see above the top dotted purple line, those are like six times the standard deviation. You see a large peak. And this means that there is a significant deviation of the amount of people in certain location after the disaster. Yeah? So in this location, it's very important for the humanitarian agencies to send support, yeah? Especially in as these are not very big disasters, so maybe nobody knows about it, but it's still happening, and people are there on different places, and they need maybe help. If you look on the right-hand side, you see not where people are, but you see how people move. Yeah? And again, this is taking away the seasonality and the trends. And what you see here is from the different antennas within 10 kilometers, 10 to 20 kilometers, and 20 to 30 kilometers, where people move. Yeah? And maybe it's not so easy to read, but you can see the blue lines. So those two quadrants at the left side, the people in those quadrants, if there is a peak, it means they move away from the closer area to the farther areas away, because this is activity in antennas, and we see an increase. We see how people move from those antennas closer by to the antennas further away. And likewise, on the top right, you see move to, and those are people who actually move closer to the landslide in the immediate time after. Yeah? So here you can see quite interestingly, even for a small disaster, that you actually see those things reflected in mobile antennas, and it is actually very, very valuable information for those agencies. Now, the last example is about recovery. Yeah? So this is again the flooding, and as we already saw in the previous slides, on the left-hand side you see again the non-completed calls. You see the high peak on the event of the flooding, and then if we select the other parts, the right-hand part, the days after the event, on the right-hand side, you see that slowly things are getting back to normal. Yeah? After a few days, everything is normal again, and that means that the community has recovered, and the people are back to normal as they were before. So this information is also very important to see and to understand for those agencies that things are getting better and are back to normal. Now, so where are we now? So big data for social good is not something new, as we've seen. Many organizations, humanitarian and also private companies, are working on it for some time. And what they've done what we've done between all of it is a lot of pilots and demonstrations and proof of concepts that it actually works. Yeah? But those are pilots, those are one-offs. You do it once, you show that it works, but then let's say nothing happens. So the real challenge is to turn those pilots into systems that work on a continuous basis, that are operational systems, such that at any point in the time, if something bad happens, then we know what's going on, we know how where to send support, and also we know where things are getting back to normal. Yeah? That's a very important contribution of big data for social good to the Sustainable Development Goals. But in order to move from those experiments and those research pilots to real-life systems, there are some challenges to overcome. The first one is related to privacy, regulation, and legal stuff. Usually, what happens is that if a company wants to participate in it, it needs to prepare its data, it needs to send it out of the company, and then it's going to be analyzed by the agency. Yeah? Now, this requires that the data leaves the company. Yeah? And in the current situation of privacy, etc., companies are afraid for their data to leave the premises, because everything can happen to it, and then it's not controlled, even if it's anonymized and aggregated data. Yeah? So there are some projects going on that look for solutions. And the solutions are in general like, instead of sending the data out of the company, we send the algorithms into the company, and the algorithms do their work, they get their results, and then the results are shared. Only the results, not the data. So we think that's a very promising solution, and there are several projects going on to make that happen. Another challenge is from the business side. Data philanthropy versus business. Because most of the projects that have been done so far, the pilots,
have been done for free. Yeah? So all the data you've seen that we've, the things we've done so far, we haven't charged anybody for those activities, even though they are of value. And if that's a pilot, a one-off, you can do that. But if this is a system that is in operation, then actually it's not for free. There is a constant cost to make it happen, to get the data there, to analyze the data, to have the systems running. So in order to be sustainable, something needs to change. Yeah? And another thing that is relevant is the cannibalization of business. So maybe you can do something for free, but maybe there also, from a business perspective, there was an opportunity to have a paid project, yeah, to charge for it. So companies have to find out what's the balance between doing things for free and, let's say, cannibalizing their own business. Yeah? Personally, I think that today it's philanthropy, but in the future it will be business. Yeah? And I always say that maybe big data for social good is the new green. Yeah? Because in the past, companies were green because they wanted to, and now companies need to be green because if they are not green, they have no business. Yeah? So that's something that will happen in this space as well. And the last challenge there is, in order for this to work, it's not only about private data, it's not only about public data, it's about combining data sets. That's where the value is. And for that to happen, you need public-private partnerships, and it's a challenge to get so many different stakeholders together and make them work. UNICEF is great with that, and they have bring all those partners together, and they are really working on to operating systems with their Magic Box initiative. Okay, so we're almost done. Key players in the field, humanitarian agencies that are relevant here are UNICEF, Global Pulse, OPAL, the Inter-American Development Bank, Global Partnership for Sustainable Data, GSMA, World Economic Forum, Pro Futuro, Data Pop Alliance, Harvard. So there's a lot of prestigious institutes that are behind this, and operators are also across the globe are very active in this space. Yeah. So at last, I would like to say that some of the things that you've seen here, we will demo at the Mobile World Congress that will start on Monday in Barcelona. That will give 80,000 people from the area of telecommunications. So if you are in the neighborhood, well, just drop by. So you can actually see and touch what I've told you in person. And with that, I would like to finish the webinar, and let's go for some questions now. So as you know, questions cannot be asked; they can only be written in the chat if you registered with your account when you connected. I want to see if there are some questions, and I have to put on my glasses to read them, I guess. So here's a question: does the mobile technology used make a difference for the type of disaster detection, 2G, 3G, 4G, LTE? Actually, I explained that. If you are in developed countries, there is not so much difference because there is the 3G, 4G penetration is quite good. If you are in developing countries, then you have to look at 2G because 3G and 4G and smartphone penetration is not so big. There is another difference between technologies. For instance, if you use calls, that means that you only get activity if people actively make a call. And that is good if there is a call, but if they don't make a call, you see nothing, no activity. If you use 4G and you use data information, if people have smartphones, they are constantly connecting to the internet. So you have a much finer granularity in terms of time. So you could find maybe the same insights with much less data. Can I put it back or not? Any other question?
Question from Miguel Solabarrieta.
Okay.
Do you have an idea how in the future these projects can be sustainable?
Well, one thing to make those projects sustainable is through the public-private partnerships. What is not sustainable is that this will be free for everybody, because there's a lot of investment needed, and in the end, you need to make it sustainable. It doesn't have to be commercial, but at least the cost needs to be paid. There is another vision on this that I read, is that while currently this is basically philanthropy, so it's for free, in the end, like other things happened with green and with supply chain management, this is going to be a must. So companies need to do this, and they need to work with humanitarian agencies for this to for being considered as a fair, but has an impact on their brand, on their reputation, and also because they probably want to do it like this.
Another question from Ricardo Leon. The aggregation of the data from the antennas could work regardless the telco owner of the infrastructure, and if so, the government has to promote this action? So can all telcos do this, and how can governments play a role in making this a big thing?
Yes, all telcos can do this, and actually the GSMA, so that's the Mobile Phone Worldwide Organization, organizer of the Mobile World Congress next week, is actually putting together a task force where it brings together about 20 operators to actually do this. So there are different scenarios. If you are an operator in one country and you have a market share of 30 or 40%, probably you are representative and you have interesting insights. But if you are smaller, then maybe what you reflect of the society is not enough to make interesting statements or valuable statements. So then you may need to collaborate with another operator. Now, operators generally compete with each other in the same countries and footprint, and here they would need to collaborate. So the GSMA is working on this. There are other relevant things that are between operators, is that some of the events, especially disease, the pandemics like Zika or dengue that are spreading across different countries, if you just monitor one country, then you lose sight. And the United Nations is not interested only within the country, but how it spreads across the world. So if you then can you can use the same methodology, the same type of data sets and the same algorithms, so you can actually follow cross-country and cross-operator how a disease is propagating through the globe. I mean, that is very, very powerful. And governments, I think, are very favorable for this. They really like it. They don't know how to handle it. Whether they need to require this data by law from the companies, or whether they have to enter into a kind of partnership with them.
We have another question here from Antonio Moneo, and he asks, what kind of socio-demographic analysis could we perform on the data? Would it be possible to cluster individuals by income?
Okay, so if this we're speaking about mobile phone data, and actually, yes, we can cluster according to certain demographic information. Remember that to all the antennas, mobile phones are connected, and the operators know of the different mobile phones, how much data they use, how much calls they make, or even what data tariffs have. Of course, you have to be very careful with privacy and individual data, but if you look at a certain antenna, then you can say, okay, this antenna represents a certain 30% of the people of the handsets connected to those antenna are let's say high spenders, 30% are low spenders. So you can make something about segmentation. Basically, that depends on how big the groups are. You can have a very fine-grained segmentation because of privacy reasons, but you can have very large segmentations in terms of income areas, maybe of gender, maybe of mobility, how people move around, etc.
And we have another question from Sim Esco, and he says, how do you propose the best ways to overcome the situation that we have several telcos in a single country? So I guess, how do we get them to work together to make this work?
Well, I think it's simply by trying to do it. Yeah. So let's take two operators in the same country and let them work together and see how it works. Yeah. So there are different models to do it. Yeah. One is that the two operators work together, which traditionally as competing company is not easy. The other possibility is that both companies send their data to the government, and the government puts it together and does it. And the third option is to have a third party, independent third party, who gets the data from the operators, then combines it, generates the insights, and provides it to the agencies or the government. There are three different models. All three have advantages and disadvantages, and I think depending on the different, there's no definite answer on what's the best way. The best thing to do is just try out several things, and I'm sure that will happen, and then we will find a way that works best for the future.
Okay.
Any more questions?
We have one last question here, which was from Ricardo again, is how do you monetize it? Who would pay, or someone has to pay for the development and deployment of these services?
Well, that is indeed the very question about sustainability. Yeah. So unless you're the Bill Gates Foundation or you're Mark Zuckerberg, then probably you can do this because you think you need to do it and don't worry about the rest. But usually companies cannot do that. So this will turn into a business. Yeah. Maybe it's not going to be a very profitable business from a revenue perspective, but I think it's companies want to do, and they need to find the ways to make it happen and to at least recover some of their costs. Yeah? So there are, in the short term, there are different ways to do it. There are also lots of, let's say, organizations like the World Bank or even the Inter-American Development Bank or the Gates Foundation. They actually can partner up with operators and other private companies and then run a project for instance, a certain country where there is a lot of problems. So it's not only that governments need to pay, but there are also, let's say, philanthropic institutions, NGOs, that might be able to pay. But really, to make this sustainable, then companies, people need to understand that this is something that is valuable and that this has a cost. So the cost needs to be paid. And in the end, I think it will be paid by the organizations, because any organization, a humanitarian organization and government today is spending a lot of money on disaster management, and using this kind of technology, I'm sure they can do it much better, quicker, faster, and cheaper. Okay, thank you very much for your attention. I hope you liked it and you got some insights. This was Richard Benjamins for LUCA Talks. Bye-bye.